Hi friends, this is Meera and welcome back to my channel. Today we will discuss how to find centroid of cross-sectional area of a dam. In this video, I am going to give you in detail step-by-step procedure to solve numerical of centroid. So keep watching till the end. You can go through my video on basic concepts of center of gravity and centroid for better understanding of concepts before we start solving numerical. You can find video in I button above or a link in the description box below. So let's begin. Suppose we want to find out centroid of the cross-sectional area of this concrete dam. We are interested in cross-sectional area, so we'll cut small section of dam. Oh, me and my plates. It gives feeling of superwoman. But incidentally, this superwoman forgot that water flow in upstream and downstream sides won't be exact same. So excuse her. And here we go. By the way, you don't want to look down at the tsunami just occurred, do you? Okay, now let's have a look at the given dimensions. So here are all dimensions we have. Let's find out centroid. In this case, first of all we will divide the whole area into more basic shapes whose centroid locations are known to us. Centroid of some shapes are given in reference books like triangle, rectangle, semicircle, quarter circle, etc. You can directly memorize this and use in numerical. So divide the area as per your convenience like this or this. Let's say we will divide the whole area like this. For complex figures like this one, I personally prefer to divide the area based on certain rules. Rule number 1 is keep number of divisions as small as possible. As you can see, we have only 3 divisions here. Second rule is divide the whole area such that at least one axis, that is x-axis or y-axis, touch as many divisions as possible. Here x-axis is touching all 3 divisions. And third one is that we should be able to find out dimensions of all divisions easily from given dimensions. These are not mandatory rules or something, but I prefer it this way. You can divide the area into any number of parts or shapes. Try it yourself for different divisions and you will see that centroid coordinates are same in each case. Next step is to locate the reference axis and find out all missing dimensions. If the given shape is not symmetric about any axis, place x-axis at the bottommost plane of section and y-axis at the leftmost section. Now check for any missing data of width or height of all parts. For triangle 1, width and height both dimensions are given, that is 2 meter width and 2 meter height. For rectangle, 3 meter width is given. Total height of rectangle is 10 meter plus 3 meter equals to 13 meter. For second triangle, width of triangle will be 14 meter of total width minus 2 meter minus 3 meter equals to 9 meter. And height of triangle is given, that is 10 meter. Next one is an important step where all required data will be calculated. Before we start calculations, let me quickly remind you the equations to find out x coordinate and y coordinate of centroid. X coordinate is equals to sigma ai xi divided by total area and y coordinate is sigma ai yi divided by total area. So to find out centroid, we will have to find out area x coordinate and y coordinate of all individual divisions denoted by I. In our case, there are 3 divisions, 1 rectangle and 2 triangles. So in general, area of rectangle is width multiplied by depth and centroid coordinates are b by 2 and d by 2 depending on position of rectangle. And area of triangle is half of width multiplied by depth, x coordinate b by 3 or 2b by 3 and y coordinate is h by 3. Also, here all dimensions are in meter, so unit of area will be meter square and unit of x and y coordinates will be meter. Now, let's find it out for triangle 1. Right now we will just focus on first triangle and ignore other two parts. Locate centroid and dimensions of triangle 1. Now, area of triangle is half of 2 meter width multiplied by 2 meter height, that is 2 meter square. The most important step is to find out x and y coordinates of individual shapes. If you know how to find it correctly, problem of centroid is very easy to solve. So now, as we know, x coordinate for this kind of position of triangle is 2 multiplied by width divided by 3. X coordinate of triangle 1 is 2 multiplied by dimension in x direction, which is 2 divided by 3, that is 1.33 meter. And y coordinate is height by 3. So y coordinate in this case is dimension in y direction, which is 2 divided by 3, that is 0.67 meter. Now check out the location of reference axis with respect to the selected triangle. As per reference figure, both x and y axis should touch the planes of triangle. Here in our case, both axes are touching the plane, so final coordinates will be same as previously calculated data and no alterations needed. We will repeat step number 3 for rectangle. So first we will highlight rectangle and locate centroid and dimensions. Now area of rectangle is 3 meter width into 13 meter height, which is equals to 39 meter square. X and y coordinates for rectangle in general are width by 2, that is 3 by 2 is equals to 1.5 meter, and height by 2, that is 13 by 2 is equals to 6.5 meter. But this method can be applied only if both reference axes touch the planes of rectangle. But it is not the case. X-axis is touching the plane of rectangle, but location of y-axis is some distance away. So some change in coordinates will be necessary. So to find out x coordinate, we have to add this distance from reference axis to the previously found coordinates of shape. This distance is same as width of triangle 1, that is 2 meter. Now area is same. Final x coordinate x2 is 1.5 meter plus 2 meter equals to 3.5 meter. And y coordinate y2 will be same 6.5 meter. Now repeat step 3 for second triangle or part 3 again. Highlight triangle and locate centroid and dimensions. Now area of second triangle is half of 9 meter width into 10 meter height, which is equals to 45 meter square. Let's find out x and y coordinates in general. For this position of triangle, x coordinate is width by 3, that is 9 by 3 is equals to 3 meter, and y coordinate is height by 3, that is 10 by 3 is equals to 3.33 meter. Again, These individual coordinates of triangle are for this location of x and y axis. Here also, x-axis is touching the plane of triangle, but y-axis is some distance away. So we have to add this extra distance to previously found x coordinate of shape. This distance from y-axis we can find out by adding widths of triangle 1 and rectangle, which is equals to 2 meter plus 3 meter is equals to 5 meter. Now again, area is same. Final x coordinate x3 will be 3 meter plus 5 meter equals to 8 meter, and y coordinate y3 will be same 3.33 meter as x axis is touching the plane. Last step is to sum up all the data we have just calculated. We just need to input area, x and y coordinates results in the equation of centroid of an area. So to find out x coordinate of centroid, we will take moment of area with respect to y axis. So total area moment will be equal to summation of moment of all individual areas. Or you can memorize this equation directly. Put values of a1, a2, a3 as well as x1, x2, x3 and we will get x coordinate equals to 5.8 meter. Similarly, y coordinate of centroid can be found out by taking moment of area with respect to x axis. So, moment of total area will be equal to summation of moment of all individual areas. Put values of a1, a2, a3 and y1, y2, y3 in this equation. So y coordinate we get is 4.7 meter.